California, known for its stunning landscapes, has increasingly become synonymous with wildfires. These fires, growing in frequency and intensity, pose significant threats to human life and the environment. The state's Mediterranean climate, with wet winters and dry summers, creates an ideal setting for wildfires. Recent trends indicate worsening conditions due to natural and human-induced factors. The Camp Fire of 2018 and the 2020 August Complex Fire are stark reminders of the growing crisis. These fires cause loss of life, property, and long-term environmental damage. Understanding the science behind these fires is crucial for developing effective management strategies. Indigenous peoples used controlled burns for thousands of years, but modern wildfires are unprecedented in scale. This essay explores the causes, impacts, and technological advancements in wildfire prediction and management. The goal is to foster a deeper understanding of California's wildfire crisis and inspire action.
Climate change exacerbates California's wildfire crisis. Rising temperatures create hotter, drier conditions ideal for wildfires. Increased heat waves and prolonged droughts dry out vegetation, turning it into flammable fuel.
Studies show a strong correlation between climate change and increased wildfires. The IPCC highlights that higher temperatures and changing precipitation patterns contribute to more intense fire seasons.
Changes in atmospheric conditions, such as reduced humidity and increased wind speeds, also play a crucial role. These factors cause fires to spread rapidly and unpredictably, making them harder to control. Addressing climate change by reducing greenhouse gas emissions and promoting sustainable land use can help mitigate wildfires.
Effective forest management is critical in preventing and controlling wildfires. Fire suppression policies have led to dense underbrush and dead vegetation, fueling wildfires.
Proactive practices like controlled burns and mechanical thinning are gaining traction. Controlled burns reduce flammable material, creating fire breaks and lowering wildfire risk. Mechanical thinning removes excess vegetation through logging and pruning.
These practices face challenges, such as precise conditions for controlled burns and community resistance.
Properly conducted, these methods reduce catastrophic wildfires and promote healthier forests. Indigenous fire management practices offer valuable insights for sustainable strategies. Understanding the historical role of fire in ecosystems helps develop effective forest management. Human activities significantly contribute to the increasing frequency and intensity of wildfires. Urban development in wildfire-prone areas raises the risk of human-caused fires. Activities like campfires, fireworks, and machinery use can ignite dry vegetation. Agricultural practices, such as certain irrigation techniques, lead to dry, flammable plant material. Faulty electrical infrastructure has caused major wildfires like the 2018 Camp Fire. Utility companies now implement power shutoffs during high-risk periods, impacting communities. Human-induced climate change, through fossil fuel burning and deforestation, creates conditions conducive to wildfires. Addressing human causes requires stricter regulations, public education, and sustainable development. A multifaceted approach is essential for reducing wildfire risk. Wildfires devastate communities, causing loss of homes, businesses, and infrastructure.
The emotional toll is immense as individuals grapple with the disruption of their lives. Wildfires pose serious health risks, with smoke and particulate matter causing respiratory problems.
Air quality deteriorates to hazardous levels, prompting health warnings and evacuations.
Firefighters and first responders work tirelessly to contain fires and evacuate residents. The scale of modern wildfires often overwhelms these efforts, highlighting the need for improved strategies.
Social impacts extend beyond the immediate aftermath, with long-term recovery challenges. Economic instability and psychological trauma affect communities for years. Support services are essential for helping communities rebuild and recover. Wildfires profoundly impact ecosystems, altering vegetation, soil, and wildlife. Fires destroy large areas of forest, grassland, and shrubland, reducing biodiversity. The loss of vegetation affects wildlife, as animals lose habitats and food sources. Some species adapt or relocate, but others face population declines or extinction. Intense fires deplete soil organic matter and nutrients, reducing fertility. Vegetation loss increases soil erosion risk, degrading the environment and water quality. Wildfires interact with the carbon cycle, releasing carbon dioxide and affecting climate change. Some ecosystems sequester carbon through regrowth, but frequent fires disrupt these processes. The increasing frequency and intensity of wildfires exacerbate global warming. Understanding these impacts is crucial for developing sustainable management strategies. Understanding fire behavior is crucial for predicting and managing wildfires. Fire behavior is influenced by weather, fuel types, and topography. Weather conditions, such as temperature, humidity, and wind, affect fire intensity and spread. High temperatures and low humidity create dry conditions conducive to fires. Wind carries embers, igniting new fires and increasing blaze size. Fuel type and condition are critical. Dry vegetation burns more intensely. Accumulations of dead plant material serve as fuel for wildfires. Topography influences fire spread, with fires moving quickly uphill and slowing downhill. Natural barriers like rivers and rocky outcrops limit fire spread. Advancements in fire science and modeling improve our ability to predict fire behavior and respond effectively.
Satellite technology revolutionizes wildfire monitoring and management. Satellites provide real-time detection and tracking of wildfires, essential for early warning systems.
Satellites cover vast, remote areas, detecting heat signatures through dense smoke. This capability identifies new fire outbreaks and monitors existing fires.
High-resolution imagery assesses fire damage, maps burned areas, and evaluates impacts. This information aids recovery efforts and improves future fire management strategies.
Integrating satellite data with GIS and remote sensing enhances wildfire response. Comprehensive fire risk assessments enable informed decision-making and resource prioritization.
AI plays an increasingly important role in wildfire management. AI analyzes data from weather forecasts, satellite imagery, and historical fire records to predict fire behavior.
AI develops early warning systems, providing real-time alerts for timely evacuations and responses.
AI optimizes firefighting strategies, analyzing data to recommend effective resource deployment. This maximizes firefighting efficiency and reduces risk to personnel and property.
AI assesses post-fire impacts on ecosystems and infrastructure, guiding rehabilitation efforts.
Integrating AI with drones and robotics enhances wildfire management. Drones provide real-time data on fire progression while robotics assist in hazardous tasks. These technologies improve safety and effectiveness in wildfire management.
Addressing the wildfire crisis requires comprehensive immediate and long-term measures. Enhancing forest management practices, like controlled burns and mechanical thinning, reduces flammable vegetation.
Improving land use planning and development regulations restricts construction in high-risk areas. Public education campaigns raise awareness about fire-safe practices.
Investing in advanced technologies like satellite monitoring and AI improves wildfire prediction and response. Continued research and development are essential for staying ahead of the wildfire threat.
Addressing climate change by reducing greenhouse gas emissions and promoting renewable energy is vital. International cooperation and policy initiatives play a critical role in these efforts. A holistic approach combining forest management, technology, land use planning, and climate action can mitigate wildfire impacts. The wildfire crisis requires a comprehensive and coordinated response. Understanding wildfire science helps develop effective prevention, management, and recovery strategies. Climate change, forest management, and human activities all play significant roles in wildfires. Advancements in technology, like satellite monitoring and AI, offer promising tools for wildfire management. These technologies must be integrated with traditional knowledge and proactive land management. Public education fosters a culture of fire safety and resilience. Addressing the wildfire crisis requires sustainable and equitable solutions, including reducing greenhouse gas emissions and promoting renewable energy. Collective action at local, national, and global levels can build a resilient future and protect our planet.